Hi, in this video we are going to discuss ionic bond. In the previous video we have discussed what is chemical bond and bond formation process and energetics of chemical bond. This is one of the type of chemical bond. Here the word ionic is from ions. Ionic bond is the electrostatic force between the ions. There are two types of the ions. One is the cation and other is the anion. Ionic bond is the force here between cation and anion and keep these opposite charge together. And these are the metals which gives cation. For example, we say that sodium is a metal. This lose one electron and form cation. After that, the second shell of the sodium is complete as it gains 8 electrons according to octet rule and gains stability. Other metals also lose electrons and form cation. Like we say magnesium is another metal which lose 2 electrons and form cation. After losing these electrons, this gain 8 electrons. This is according to octet rule. While on the other hand, these are the non-metals which give anions. For example, chlorine is a non-metal. This gain 1 electron and form anion. And after that, it's gained 8 electrons in the valence shell. This is according to octet rule. So non-metals gains electrons and complete their valence shell. Oxygen is another non-metal which gains 2 electrons and form anion. This also complete their valence shell by gaining electrons. So we can say that these are the metals and non-metals which form ionic bond, as metal give electrons and non-metal receive that electrons. For example, sodium chloride is ionic compound. Here the bond between sodium and chlorine is ionic bond. Here sodium is a metal this give electron and form cation. And chlorine is a non-metal. This receive that electron and form anion. We can write these two steps in this way. Here sodium give electron and chlorine receive that electron and form sodium chloride ionic compound. So we can summarize ionic bond is a type of chemical bond which form when metal give electron and non-metal receive that electron. In this way, by losing electron and by gaining electrons, metals and non-metals complete their valence shell and gain the stability or electronic configuration like noble gases. As, as sodium and chlorine gain the electronic configuration like neon and argon. Every ionic compound has ionic character, and this is electronegativity difference and Fajan rules that decide the ionic character. There is no 100% ionic compound. Every ionic compound has covalent character. If the electronegativity difference between the atoms or between metals and non-metals is higher, then the ionic character in that compound will be higher. For example, we say that in hydrofluoric acid, the electronegativity difference between these two atoms is 1.9. And in hydrochloric acid, the electronegativity difference between these two atoms is 0.9. So we can say hydrofluoric acid is more ionic as it has greater electronegativity difference. And if a compound has electronegativity difference 1.7, in that compound there will be 50% ionic character and 50% covalent character. We can derive from here if the electronegativity difference is greater than 1.7, then the compound will be ionic as hydrofluoric acid, and if the electronegativity difference is less than 1.7, in that case the compound will be covalent as hydrochloric acid. There is a Linus Pauling formula that tells the percentage of ionic as well as covalent character. This is the formula from where we can calculate the percentage of ionic character. Here E is a constant, and this delta chi is the difference between electronegativity of two atoms. For example, in sodium chloride, we can calculate the percentage of ionic character from this formula, as the electronegativity of sodium is 0.9 and chlorine is 3. Here the electronegativity difference is 2.1. So by simply adding this electronegativity difference, we can calculate the percentage of ionic character. Here E is a constant which is always equal to 2.71. So by simply solving this equation, we can calculate the percentage of ionic character, which is 67% in case of sodium chloride compound. In a compound, the percentage of ionic and covalent is always equal to 100. So from this we can calculate the covalent character, which is 33%. There is no compound which is 100% ionic. Cesium fluoride. This is one of the most ionic compound which has 92% ionic character and 8% covalent character, which has electronegativity difference 3.19. There is no compound which has 100% ionic character. This is because every atom has electronegativity and there is no atom which has zero electronegativity. This do not allow complete transfer of electron. And in case of homoatomic molecules like oxygen and chlorine molecules, these has electronegativity difference 0, as these has same atoms. So these molecules are 100% covalent. So we can summarize, there are the molecule or compound which are 100% covalent and there is no compound which is 100% ionic. On the base of cation and anion effect, Fajan's rules also tells about the ionic and covalent character. As if the size of the cation is smaller, then in that case there will be the more covalent character. This is because small cation has higher charge density. We do not allow complete transfer of electron. So the compound will have more covalent character and less ionic character. As the ionic compound is formed by transfer of electron. For example, in case of beryllium chloride and barium chloride, beryllium and barium belong to same group, but the size of the beryllium is smaller as compared to barium. This is because as we move from top to bottom the size increases. So here beryllium chloride will be more covalent and barium chloride will be more ionic compound. And if a cation has higher charge, there will be more covalent character. For example, in case of aluminum chloride and sodium chloride, aluminum has +3 and sodium has +1 charge. So sodium chloride will be more ionic and aluminum chloride will be covalent. While on the other hand anion also affect the ionic and covalent character. If the size of the anion is large, there will be more covalent character. For example, in cesium iodide and cesium fluoride. Here the size of iodide is higher, so cesium iodide will be covalent and cesium fluoride will be more ionic. So on the basis of electronegativity difference and Fajan's rule, we can decide the ionic as well as covalent character in any compound. Let us now discuss some properties of ionic compounds. Ionic compounds always have formula unit. This is simple ratio of ions in a huge crystal. Ionic compounds do not exist independent in molecular form. Ionic compounds exist in crystal lattice. These are the ions in ionic compounds which arrange in three dimensions and form huge crystal which is known as crystal lattice. Here, in huge crystal or crystal lattice, the simplest ratio of ions is the formula unit. In that huge crystal, there is a repeating unit which repeat again and again and form crystal lattice. This repeating unit is known as unit cell. For example, in case of sodium chloride crystal lattice, there is face-centered cubic unit cell which repeat again and again and form sodium chloride crystal lattice. Here in this unit cell, there are 8 corners and 6 faces where chloride ion exist. As we can draw the unit cell. In this unit cell there are 8 corners where chloride ion exist and each is shared by 8 other units. So there is one chloride ion in one unit cell. And this unit cell has 6 faces. At the center of each phase, chloride ion exists and each phase is shared by 2 other unit cells. So in one unit cell there are 3 chloride ions. So overall there are 4 chloride ions in one unit cell. And there are 12 atoms and one body center where sodium ion exists. 12 atoms and one body center in the same unit cell we can draw in this way. There are 12 atoms and one body center where sodium ion exists and each atom is shared by 4 other unit cells. So there are 3 sodium ion in one unit cell and one body center sodium belong to only one unit, so there is one sodium ion in body center. So overall there are 4 sodium ion. So we can say that one unit cell contains 4 sodium and 4 chloride ion. In this unit cell, chloride and sodium ions have 6 coordination number as each chloride ion is surrounded by 6 sodium ions and each sodium ion is surrounded by 6 chloride ions. Ionic bond is the strongest bond, so ionic compound have high melting and boiling point like sodium chloride which has 801 centigrade and 400 plus centigrade melting and boiling points. Ionic compounds are brittle. Ionic compounds are made up of opposite ions and when we apply stress, the same ions come face to face which repel each other. So these compounds are brittle. Ionic compounds are soluble in water and creates ions. So ionic solution conduct electricity. When we dissolve in water, this is the oxygen atom or water molecule we develop the attractive force is with cation, and this is the hydrogen atom, a water molecule which develop attractive forces with N9. Ionic compounds having the strongest bonds are solid at room temperature and have non-directional forces. Thanks for watching, and please comment if you have any question.